Today we're going to be talking about third-party dependencies. But before I get into that, I've got to ask, what's the weather like where you're at? Obviously, I've been spending a lot more time at home lately, but still been trying to get out into the neighborhood for a walk once a day. And after spending the day cooped up out inside, I've got to wonder before I head out, should I put a sweater on? Obviously, that's it's partially dependent on the weather outside and personal preferences. But the Weather Channel tried to answer that question a few years ago by running a survey where they asked people what they thought the start of sweater weather was. And in the United States, the answer was between 55 and 65 degrees Fahrenheit. That obviously differed between regions, and where I'm at in Massachusetts, the average was 57 degrees Fahrenheit. So today, we're going to build a system to help answer the question, is it the start of sweater weather? My name is Kevin Murphy, and I'm a software developer at the Gnar Company. We're a software consultancy in Boston, Massachusetts. So let's start to think about what it would look like to build one of these systems. One of the core things we need is the ability to know what the temperature is. And right now, the temperature I care about is really just hyper-local, right? I really just need to know what it's like right outside my window. So I could pull the Raspberry Pi I have out of the closet, stick a temperature probe connected to it, and put that out the window, and that'd be sufficient. But hopefully, sometime soon, it will be safe to go out and about throughout the world, and I might want to know what the temperature is in other places, right? Like the office or my parents' house the next state over. And I suppose I could address that by deploying a fleet of these Raspberry Pis that I can connect to figure out what the temperature is where I care about. But it's not a very scalable solution and not very general purpose, right? If anyone else wanted to use this, they'd have to have very specific interests, which is the weather where I care about. So I guess what I really need is a weather satellite so that anyone can figure out what the temperature is where they're at, and probably a rocket ship to be able to launch the satellite into orbit. But I also like building redundant systems, so I probably need a couple of these things. And all of this is to say that this presentation is really just my pitch deck for my latest startup, Sweather, which brings you the latest in real-time notifications if you should be wearing a sweater. And this is a great opportunity for anyone looking for a new investment. All I need from you is probably something in the realm of $11 billion. Or, I mean, maybe 22 billion. I'm going to be honest, I don't really know. I have no idea how much a weather satellite costs. And other than the obvious reasons why I don't know what a weather satellite costs, the main one is I would never actually propose that we do this if we were building this system, right? Um, we can and will build Sweather in this presentation, but I can build it on top of an existing system that can tell me what the temperature is. And then Sweather will add the value of if you should be wearing a sweater. This other system is a weather API, and in this example, that is our third-party dependency. And in this presentation, this dependency is an HTTP API, but the methods we're going to discuss for testing this HTTP API hold just the same as if it were any other kind of dependency, whether it be a persistence layer or a message queue or even just someone else's code. So let's start to build Sweater here. The main thing is going to be a location class that answers the question if it's sweater weather. And we're going to build up a URI that is the URL that we need to communicate with for our weather API. We're then going to issue a GET request. And I know that that gives me back JSON, so I'm going to parse that out to get a hash. And I know what the response structure looks like, so now I can get the information that I need out of it, which is what does it feel like outside? And then I can figure out if it's between 55 and 65 degrees outside, and I can tell you if it's the start of sweater weather. So here it is. We basically already built Sweater. So again, if anyone's looking for an investment opportunity, I've got a working product ready to go. Well, I guess you're sort of taking me at my word that it works, so I'll prove it to you. We'll build a test. Right? We'll new up a new location, and we'll ask if it's sweater weather, and we'll assert that it's true. Now, when I was originally writing this test, it was an unseasonably warm day where I'm at, and it was about 70 degrees out, and I ran the test and it failed, which was disappointing. And I guess I'd rather not tell you as potential investors, but I just want to come clean. But I didn't have a lot of time to look into it, so I had to move on with my day, and I got back to it around dusk. and my test passed. So I was feeling really good about things, and I was making some other changes to the system, and then ended up running the test suite later on, and it failed. And that was disappointing. But then I realized uh, the reason this test is passing or failing has nothing to do with my system itself. The problem is this test is literally dependent on what the weather is outside. Every time I run this test, it's asking the weather API what the temperature is. And so whether it's sweater weather or not depends on what the temperature is outside. So in this test, I'm directly interacting with my dependency. And that has a lot of benefits. Right? When I'm executing this test, I'm pretty confident when it works that it's going to continue to work because I'm using the real thing. Right? So when I roll this out into production, I don't have a lot of concerns about if it's going to interact differently. It's the same exact thing that's going to run. Right? However, this test is also pretty slow. Right? I have to issue an actual API request. And as we've seen, sometimes it's going to pass and sometimes it's going to fail. Right? It's literally dependent on the weather. Right? Now, even in situations that aren't as fickle as that, you might have a situation where the server goes down and then your test suite doesn't pass. This also means that you need to have access to the dependency, which seems kind of silly, but this means that I can't run this test suite if I don't have access to the internet, right? Or if my dependency was between some VPN network connection that I wouldn't have available to me all the time, I would have a problem. My test wouldn't pass. I might also have an issue if my dependency has some sort of rate limiting, right? If I can only issue X number of requests over a Y period of time, particularly if I'm working in a team with a CI server and we're all sharing an account, I don't want to be in a position where I tell people not to run their tests frequently for some reason. But there is merit in using this approach. Right? It's particularly valuable when you've never used the dependency before. Right? It's not worth putting the effort in to imagine how your dependency might interact. Right? Just actually use the real thing and get a handle on it. Figure out how it works. And also, it's beneficial to use when it's just so darn easy to do it. So in a lot of Rails apps, we probably have model tests that we consider to be unit tests that are interacting with a database. That database is a third-party dependency, and from an academic perspective, not a unit test because it's interacting with an external collaborator. However, the cost for that one particular test is so low and it's so easy that sometimes it's a worthwhile trade-off. It still has all of the baggage that comes with that we talked about in the last slide. Of it's slower and it's dependent on the dependency, but it might be a decision worth making. For our purposes, this pattern obviously isn't going to work, right? We want to make sure our tests pass consistently. So let's try something else. Let's try stubbing out the response. And so here we're going to prepare some JSON that says it's always 55 degrees outside. And again, this is an HTTP API, so we're going to use a tool called webmock. And what webmock is going to do is going to say, anytime in my test that I issue a GET request to this particular URL, I don't want you to actually make the API request. Instead, I want you to just return a 200 with the response that I just gave you up above. Okay. So now when we run the same test, this is always going to pass, assuming our implementation is correct, because the API is always returning that's 55 degrees because it's not actually issuing an API request. So this is wonderful, right? Now our test will pass every time unless there's something actually wrong with our code. It also means we don't even need the dependency, so I can run this test suite when I don't have access to the internet. It also brings us closer to that academic definition of a unit test, because I don't actually need the dependency. However, I needed to have some knowledge or intuition to be able to set up this test correctly. I needed to know what the JSON response was that I care about that the API is going to return. And moreover, I need to keep that up to date with reality. Right? These response values are hard-coded, and there's nothing saying that the dependency couldn't change over time, and if my tests aren't updated, then I have a situation where my tests pass, but production is going to be on fire because my code wasn't set up to handle how the response changed and I didn't know about it. Last concern here is, a bit of a stylistic concern. Depending on your response and how much of it you need, you might have a lot of code in your test that's just uh, preparing what's going to be responded from your stub. And maybe that takes away some of the value or difficulty in reading your test. Okay. So I find stubbing to be a particularly effective approach when you're working with a dependency that is very stable. Right? That way it's unlikely to change. This minimizes the risk or concern that your response that you've hard-coded gets out of date with reality. It doesn't make it go away, but it makes it less likely to occur. And lastly, if you care about the verbosity of your test setup, you might only prefer stubbing in situations where you only care about a small part of the response, or if the response itself is particularly small. Okay. So maybe this stubbing is a bit too much indirection. You'd like to see your code actually be exercised a little more than this is actually doing. And that's totally fine. We can take care of that. Let's build a fake. And what a fake is an actual version of the dependency that's going to stand in for the real one. So in this case, we're going to build our own weather API. And I know this is RailsConf, but just for ease of fitting everything on a slide, I'm going to build a Sinatra application. Okay. Our Sinatra app is going to have one route. That route is the same as the real weather API. And it's going to return JSON that looks the same as the real weather API. And now if we go back to the test we've been working on, I'm going to use a tool called Capybara Disco Ball, which is going to take the code that's running, and anytime that I issue an API request, rather than sending that API request to the actual dependency, it's going to instead use my fake weather application instead. So now, when I ask if it's sweater weather, this is going to be true because my fake weather web app always says it's 56 degrees anywhere in the world. So this is neat because this is a full stack test in that it's actually issuing an API request. It just happens to be to a local server that we have set up just for the purposes of our test. So we have everything we need on our local system. We've also taken away any of the concern of having all of that noise in the setup, but moved it into a separate file. And we can make this fake as simple or as complex as we need it to be. For the purposes of our test, just having it be 56 degrees everywhere all the time is perfectly fine, but there's nothing stopping us from making our web app say that it's always 12 degrees in Alaska and 70 degrees in Alabama, and on every third Tuesday where the moon is full, it's -2 degrees in any particular zip code. Right? It just depends on what needs we have. However, we still have the same problem that we had with stubbing, where we need to make sure that the fake responds the same way as the real thing. Right? The route needs to look the same way, and the response needs to be of the same structure and give you the same information. Right? And then we're also just adding more complexity. Right? So I started this presentation with sort of a silly notion that we were going to launch weather satellites into orbit in order to be able to tell what the weather was. And now what I'm proposing is that we build a whole application that tells you what the weather is somewhere just for the purposes of testing our interaction with another system that tells you what the weather is somewhere. Right? And now when if a test fails, we now have to figure out, is it a problem with our test? Do we have an actual bug in our implementation? Or did we do something wrong with our fake? Right? And then do we need tests for our fake? And how do we make sure we have confidence that our fake system is working the same as the real system does? So I find fakes to be an effective method of testing with third-party dependencies if you're particularly interested in testing the communication mechanism. So if I were building an HTTP client library, I probably want some tests in there that actually make HTTP requests, because that's incredibly important for what my library does. But I probably don't want to be reliant on an external system, so I can build my own web app that I use in tests and just use that. Fakes can also be particularly valuable when you're looking to test something that has multiple steps between different systems. So, for example, if you're testing an OAuth handshake, you could build a fake web app that responds to whatever side of the OAuth handshake you're testing the other part of. And that way you don't have to interact with a real system, but you don't have to have like this big long stubbing of, however many different API requests and responses in there. You just build your web app that responds to the same routes and does the things you need. So this will work perfectly fine for us. But it has a lot of machinery complexity, right? We had to build our own web app, and maybe we don't want to have to worry about that. Well, we have another option we can investigate, right? We can use fixtures, and fixtures are just files that document particular requests and responses that occurred, and then replay them on subsequent invocations of that request. So let's look at this by way of example. We have the same test that we've been looking at this entire time, and we're going to use a tool called VCR to generate and manage these fixtures. VCR very much leans into the terminology of it being a system that replaces a VCR. If you don't know what a VCR is for the purposes of this analogy, it's a thing that we used to use to be able to watch movies on our TV at home before DVD players. And if you don't know what a DVD player is, it's a thing we used to use to watch movies at home before we had streaming. So what VCR is going to do is it's going to look for an existence of a fixture, which it calls a cassette. And the first time this test is run, we're not going to find one. So we're going to issue an actual API request to the real weather API and get an actual response back. VCR is going to keep track of all of the information we sent over and received and store that in a file and save that. And now the second time we run this test, VCR is going to notice, oh, I already have this fixture. So I'm going to use that to stand in for the actual API request. So the second through nth time that we run this test, this isn't hitting the actual weather API, it's using the fixture instead. So this is cool because we have absolute truth at a particular moment in time, right? We've documented the exact request we sent over and the full response we received, right? We get the complete picture of everything that we sent over and everything we got back. Right? Can also make our test a little difficult to read, right? We don't really have any strong indication as to why it's sweater weather when we just look at the test. Instead, we'd have to open up the fixture and notice, oh, in the response it said it's 58 degrees, that's why it's sweater weather. We also have the same problem in the fake, where you need to look into how the fake is set up to know why it's responding this particular way. It's also great that it's absolute truth at a particular moment in time, but unfortunately that moment in time is immediately the past. So there's no guarantee that in the future or even in the present that your dependency still interacts that way. So things can get out of sync and out of date and become stale. And to be able to generate this fixture and keep them up to date, we've got to be able to access our dependency, right? Which, may be a challenge depending on what we're looking to do, right? So fixtures can be beneficial if we need the full response. We need to keep track of everything that comes back. Right? Maybe we want to use it as documentation of how the API interacts. Or maybe we just care about more information than just the one thing that we care about. Right? The weather API that we're using here returns hundreds of data points. We just only care for this example about one of them. But if we cared about all of them or some substantial number, this may be more beneficial than stuffing out a big long response. Again, we need to have access to the dependency to generate the fixture, so it really only applies in situations where we can readily access it. Right? And fixtures are really most beneficial when regenerating them won't cause any adverse effect on the dependency. Now, this isn't that obvious with a weather API, So let's consider an example where we were testing the use of some third-party user registration service. Right? So we want to test making an API request to register a user and make sure it works. And so the first time we do that, everything works perfectly fine, and we save that fixture and we use that going forward. But then later on, we want to change that fixture and just keep it up to date, right? Because it's been a certain amount of time. Let's just run it again. And we run it the second time, and our test is going to fail probably because that user registration system probably has some uniqueness validation on email address. So now whenever we want to regenerate the fixture, we need to change our test to be some unused email address. Or if we have access to the user registration service, we need to delete that username or email address from the system before regenerating the fixture. And all that this means is that it's much more unlikely that we're actually going to continually refresh these fixtures. And the ability to do that and make that as seamless and easy as possible is very important because we want to minimize the risk that these things become out of date and make sure that our system still reacts the same way that we expect it to. So let's take a second and think about what we've done here. We've investigated 4 different ways to test a third-party dependency, but let's look back at our implementation and take a closer look as to why we had to do that. Everything in this method isn't super complex, but there's still a lot going on here. Right? I mean, it's not very large. It all fits on a slide, so that's good. But really, the business logic we're testing is just a number comparison between 2 other numbers. But in order to test that part of it, we need to take the whole kit and caboodle with it. Right? This test is doing a number of different things. Right? It has this whole block here that's interacting with our dependency. Then we have this section that's taking out the relevant information that we care about. And then lastly, we have our piece of code, which is just saying, is this number between those other numbers? But we can't test this last part without the other parts, the way this is set up. So let's decompose this a little bit into different classes. And let's start at the top. We'll build an API client. The API client is going to be solely responsible for issuing a request and getting a response back, and then making it someone else's concern to do anything meaningful with that. So it's going to build up the URI, much like the initial implementation, issue a GET request, and we'll parse the JSON to give it a hash back just for convenience. So now we need to test this, but we're pretty familiar with a number of different ways to test this. So let's just choose a fixture because it happened to be the last one we talked about. And so similarly as before, we're going to exercise the API request, get a response back. And what I'm going to assert here is not that we got any particular value back, but that the structure looks a certain way. Now, the API class itself doesn't really care about the structure here at all. All it cares about making sure is that it made a request and it got a response. At that point, it did its job. However, this layer of the application is going to be the part that's actually interacting with the dependency. So we want to have its tests serve as an early warning system that anything changed in the actual dependency. Right? And it's very important to us for our application that this response returns some JSON that is composed like this and has this information in here. But it's not very important that it's any particular temperature at a given time, right? Whether it's 56 degrees or 72 degrees. So I don't want this test to fail for that reason. Particularly because I want to make this as easy as possible to regenerate these cassettes, right? So I should be able to regenerate this cassette every time, or not even have the cassette at all and directly interact with the dependency, and this test should continue to pass, unless the structure changed in some way. That way, this test failing gives me valuable feedback. Okay. The second thing we need to do is to be able to take that response we got back and translate into meaningful values that we care about. So let's build a Ruby object here called current conditions that takes in a hash. That's the response that we got back from the API. and it responds to methods with the information we care about. In this example, what the temperature feels like outside. And just like before, we'll dig into the hash and get the piece of information that we need. But we're also going to convert it to a float, because it turns out that the API gives me back a string, and I don't really want a string, I want a number. And now to test this, I can test this in complete isolation as just a regular, input-output Ruby test, right? So given this particular JSON, I expect this particular result. And this is where it made it really easy to know that this isn't giving me, the API isn't giving me back a number, it's giving me back a string. Right? Because originally this test failed because the string 55.5 is not the number 55.5. And so that tipped me off that I had to actually change something to be in a meaningful representation that we care about for our application. Right? And then because this is just given particular input, expect certain output, it's very lightweight and easy to be able to build all sorts of edge cases without having to have all of the machinery and rigmarole of setting up some way to interact with the third-party dependency and have it give you these results back. Right? All you need to do is, given this particular set of a JSON hash, here's how our data representation is going to react under these conditions. We need to tie these things together. So I like to build a domain class, or in this case, a domain module. We'll call it a weather module. And the weather module is going to interact with the API and give us back the information that we need. So it has our API client, and it has the ability to tell us what the current conditions are for a given zip code. And this method here is going to make an API request with our client, give those results to our current conditions class, and then any consumers of this or callers of this can do whatever it is they need to do with the current conditions. Okay. So let's see how we would use this domain module in our sweater implementation. So we're back to our sweater weather method. And now we're going to use that weather module to ask it what the current conditions are at this zip code. And we're going to pull out what the temperature feels like and figure out if it's between 55 and 65 degrees. And that's it. Now this method is solely responsible for getting some information and performing our business logic. It doesn't care about how it gets the information. That's the responsibility of the weather module. One change I'd like to propose to the weather module is not only the ability to tell us what the client is, but also the ability to set the client. Right? So given any particular class, be able to have the client be whatever we tell it to be. And that will allow us to build and use a fake client that we could then dependency inject into the module and use that instead of the real thing. So much like our fake web server that we built, our fake client needs to respond to the same messages that the real one does and respond in the same way that the real one does. But our fake client can also respond to additional messages. So let's build an additional method here that lets us provide some preconditions to say, for any given zip code, here is the temperature. So now in my test, I can control the weather anywhere. That only exists for my particular test. But I can set up the state of the world before running my test. Okay? So now I can use this more easily by building out something called a test mode, which is just another module that has two methods. You can enable test mode, which sets the client to be this fake client. And you can disable test mode by setting the client to be the real one. You don't explicitly need this testing module. Right? You can just do this in your test code, but I find having this module just makes it a little easier. Right? You don't have to worry about how it does it, just that it does it. So now let's look at how our test would change using test mode. Right? So we're going to test the exact same thing. First, we need to turn on test mode. Right? And then we're going to use that add condition method to set up the state of the world. We're going to say, for the purposes of this test, it is currently 56 degrees at this zip code. Right? Then our test is going to look just like it did before. we're going to new up a unit under test, ask if it's sweater weather, assert that it's true. But we have one more step we need to do in this test. We have some teardown where we want to turn off test mode, right? We may have some other tests that are expecting to make an actual API request, or if we don't, we just want to be a good citizen and not globally change the state of the world throughout our entire test suite. So, test mode is beneficial because it's, should be at least, faster than using the real thing. Right? This is performing all of its work in memory as opposed to having to make any sort of API request at all, ever. We also have a lot of control of the state of our system. Right? Similar to the fake web app, right? We can say that it's any temperature at any particular point in time. But we have a bit more benefit in test mode where we can make that obvious in the test itself. Right? The test itself said it is currently 56 degrees at this zip code, as opposed to needing to have to look into the fake class to say, why is this reporting that it's 56 degrees? We can also bolster the functionality of the test mode to insert some functionality to keep track of interactions with the client. Right? So we can know if any particular block of code made 7 API requests or 0 API requests, and then we can build assertions based off of that. This also means that we're not interacting with the dependency at all, which may be perfectly fine, but has the same issues that we've had with stubbing and building a fake, which is that we need to make sure it stays up to date with the real thing. Here, it's really the API of the API class, but ultimately that still means the third-party dependency, because the response that comes back from the API class is going to change based on what comes back from the third-party dependency. So I find test mode can be very valuable when you have coverage of your interaction with the dependency somewhere else. And in the way we set up our code right now, we do, because we have that separate client class that is responsible for testing its interaction with the dependency. And then any layers above that don't have to worry about talking to the actual dependency. Test mode can also be beneficial when you need to keep track of some of that metadata information. Right? So if I need to keep track of the number of API requests we made in a particular block of code, we can do that, or make sure that this didn't ask what the temperature is in Alaska, but it did ask what the temperature is in Massachusetts. So the purpose of this talk was to discuss how to test third-party dependencies in our applications. And ultimately, my conclusion is don't. And what I really mean by that is to avoid it most of the time. Instead, build enough layers of separation between your dependency and your business logic so that you don't have to worry about it in every test in your system. Right? So here we built a client class that we then handed off the results to a data representation that we use both of them in a domain module, and that's what our business logic used to do some meaningful work on. So now when we're testing each of these things, we still need to test that the client interacts with the third-party dependency correctly. And we can use any of the methods we've talked about in this presentation to do that. But in any of the other layers, like in the data representation or the domain, we can test those in complete isolation. We don't need to worry about how the third-party dependency reacts. At most, we need to worry about how our client class interacts. We need to have the confidence that our client class tests sufficiently cover how the API responds. And then in our business logic, we can use test mode to not have to worry about how any of this works, because all we care about, for our example, is what the temperature is at some position in the world. Right? And then in our application, the concern is how do we react to that? So when you're testing third-party dependencies and when you're building systems and architecture that work with third-party dependencies, I recommend that you build enough layers of abstraction to limit your interaction with them, which still allow you to test confidently. Right? still have those lower layers working with the actual dependency and have those tested independently. But you don't have to build up all of that interaction at your higher levels of abstraction because you have the confidence that those lower layers are going to take care of that for you. If you're interested in a copy of these slides, or if you'd like to see the Rails application that was used to generate all of the examples in this slide deck, you can visit my GitHub page. My username is kevin-j-m, and the repository is testing services. I'm also on Twitter at Kevin_J_M. Please give me any sort of feedback or questions you might have. I'd love to hear from you. And otherwise, thank you very much for your time, and I hope you enjoy your day.